In this lesson, we're going to determine the number of protons, neutrons, and electrons in isotopes. Now, there's two different ways that isotopes can be displayed. We have the notation here on the left-hand side, and we have the notation on the right-hand side. We're going to go over both, but we're going to start with the one on the left. You can see that we have the name of an element, there's a hyphen, and then there's a number. We can also write this with the symbol of the element, a hyphen, and a number. And we call this the hyphen notation. Now, in this hyphen notation, the number that comes after the element's name or the element's symbol is the mass number. Protons have a mass of 1 AMU, neutrons have a mass of 1 AMU, and electrons basically have a mass of 0 AMU. So when we want to figure out the mass of an individual atom, we ignore the mass of the electron and we just add the protons and neutrons together since they both have a mass of 1. So let's try some practice. In this example, we're going to assume that all of the atoms are neutral. I'm telling you that the element is oxygen, and I told you how many neutrons are in this example. And we need to try to figure out the number of protons, the number of electrons, and the mass number. So we need to remember that it's the protons that identify the element. So if we know the element is oxygen, all we need to do is find it on the periodic table. We see that its atomic number is 8, which means the number of protons has to be 8 because the atomic number is the number of protons. Now, in a neutral atom, the number of positive charges has to equal the number of negative charges. So if we have 8 positive protons, we need to have 8 negative electrons. And our mass number is the sum of the protons and the neutrons because they both have a mass of 1. So it's going to be 8 plus 10 gives us a mass of 18. Remember, we never include electrons in the mass number because electrons have virtually no mass. And it's the mass number we write after the element in the hyphen notation, so it would be oxygen 18. Now it's your turn to practice one on your own. I gave you the number of protons and the number of neutrons this time. You need to figure out what element it is and determine what number comes after the hyphen in the hyphen notation, how many electrons there are, and the mass number. Pause the video while you work, and when you're ready, start the video up again. Let's see how you did. We're going to need to refer to our periodic table. And remember, the number of protons identify the element. The protons are the atomic number. And as we zoom in, we can see that that would be arsenic. So we know the name of the element is arsenic. We know that there has to be 33 electrons because the total positive charge and negative charge has to be equal. And we find the mass number by finding the sum of the protons and the neutrons. So 33 plus 42 is 75. And we write that mass number after the arsenic in the hyphen notation. Let's try one more example. This time I've told you the number of protons and I've given you the number that goes in the hyphen notation. You need to determine what element it is, how many neutrons, how many electrons, and what the mass number would be. Pause the video while you work, and when you're ready, start the video up again. We're going to need to take a look at a periodic table. Number of protons is 15, which would be phosphorus. Remember, our mass number here is 31. This would be the protons plus the neutrons. So if we know that there are 15 protons and we want to find the number of neutrons, we need to subtract these two numbers. And that comes out to be 16. The number of electrons has to equal the number of protons in a neutral atom, so that would be 15. The mass number is the number that comes after the hyphen, so that would be 31. Another way these can be written is the nuclide notation, also called the isotope notation. And with these, you would have the symbol of the element, and in the lower left-hand corner, you would have a number which will represent the atomic number. Remember, the atomic number is the number of protons, and if it's a neutral atom, the number of protons and electrons would be the same. You'll also see a number in the upper left-hand side. That's going to be the mass number. Remember, mass number is the number of protons plus the number of neutrons. So let's do a few example problems. So let's see, the number of protons is equal to the atomic number, which is always the number here in the bottom left. So for protons, we're going to have 7. The number of electrons and the number of protons is the same in a neutral atom. Remember, the mass number of 15 is protons plus neutrons. The atomic number of 7 is just the protons. So in order to find the number of neutrons, we're going to want to subtract those two numbers, and 15 minus 7 will give us 8. The atomic number is the bottom number of 7, and the mass number is the upper number, 15. All right, now you're going to try one on your own. Pause the video while you work. So let's see how you did. Remember, the bottom number, the atomic number, is the number of protons. So there would be 92 protons. In a neutral atom, the protons and electrons are equal. To figure out the number of neutrons, we're going to subtract the atomic number from the mass number, or subtract the protons from the mass number. That comes out to be 143. The atomic number is always the number in the bottom left, which is 92, and the mass number is the number in the upper left, 235. Sometimes we're going to have ions, and when there is a charge, it's written in the upper right-hand side of our nuclide or isotope notation. So this tells us that overall, there's a positive 4 charge. So let's see if we can figure out the number of protons and neutrons and electrons. We should remember that the number in the bottom left is always the number of protons. To find the number of neutrons, we need to subtract the atomic number from the mass number, which comes out to be 6. So the number of neutrons is 6. In this case, the number of electrons is not going to equal the number of protons because this is not a neutral atom. This is an ion with a +4 charge. Well, we've already determined that there are 6 protons. Now, in order for this to have an overall positive 4 charge, there have to be 4 protons that are not going to be canceled out by an electron. So this ion is only going to have 2 electrons in it. And here we have this proton canceled by the electron, this proton canceled by an electron. But these 4 protons up here are not going to be canceled by anything, and that's going to result in a positive 4, 1, 2, 3, 4 charge. Another way to look at it is 6 positive protons plus 2 negative electrons results in a positive 4 charge, or 6 plus a negative 2 equals positive 4. I want you to find the number of protons, neutrons, and electrons in this ion. Pause the video while you work, and when you're ready, start the video up again. So let's see how you did. Remember, the number on the bottom is the atomic number, which is the number of protons. Remember, the mass number is the protons plus the neutrons. The atomic number is just the protons. So to find the number of neutrons, we need to subtract those two numbers, and we get 8. Now we know we have 7 protons. And to be neutral, we would need an equal number of electrons. But this particular isotope is not neutral. It has an overall -3 charge, which means we need to add more electrons, because each electron comes with 1 negative charge. Since it's a -3, we have 3 more electrons than protons in this ion. We know there are 10 electrons in this case because 7 positives plus 10 negatives result in a -3, which is the charge on this ion. You did a great job today. Thanks for joining me, and I will see you soon.